Howdy everyone, and welcome back. And we've been talking about some optic stuff. We've been talking about basic lenses and mirrors with the optic equation. We've been talking about some weird quantum light interference stuff, leads us to quantum mechanics. But today I want to talk about something very practical. I want to talk about specifically glasses and prescriptions and applying some of the sort of things we learned and put it into a real case. So I'm going to figure out, for instance, if I know roughly when things start going blurry, either near or far, how do I actually figure out what kind of prescription glasses do I need? So that's what we're going to talk about today. We're going to do a nearsighted person, we're going to do a farsighted person. We're just talk about what those look like and how do we compute it in those cases. So here we have a farsighted person, so they can see infinitely far away. They can see as far away as they want, but at some point they actually can't see close enough until it starts going blurry again. So they have a near point, so this is the closest point that they can see before something gets blurry. Now most average adults, the average adult, middle-aged adult, can see 25 centimeters in front of them. So that's quite a bit closer than what's here. So if, effectively if you want to read, you need to have some sort of corrective glasses for this person. So essentially what we want to do is that we have an object at 25 centimeters and we want to make it so a lens puts an image at 60 centimeters because that's actually the closest they can see. So when we put on glasses, it does distort things a bit, but this does make it so they're able to clearly see these sort of things. So how do we compute that? How do we get a prescription for them? So let's start with the lens equation. So here we have it, the classic lens equation, 1 over the focal length equals 1 over the distance to the image plus 1 over the distance to the object. So we've talked about this algebraic trick before, but you could always multiply by 1. So 1 is, in this case, is just the distance of the object over the distance of the object. And the same thing over here, distance of the image over the distance of the image. And so why we do that? Well, then when they have the shared denominators, then we can just simply add the tops. It's no problem. So we get 1 over the focal length is that stuff. We can get the focal length by just flipping everything. So we end up with this equation. And so we have to be very careful with the distances to the images and the objects that we put in here, because otherwise we're going to get a little bit messed up. So distance to the image, okay, I got the things messed up here. Distance to the object is going to be 25 centimeters. So we have that here. That's this distance. And the distance to the image, 60 centimeters, but it's not positive. It has to be negative. And why is that? Well, we talked about the sign conventions of lenses, and when it's on the same size of the object, there's got to be a negative sign difference between them. Usually we keep the object as positive and the image as negative in that case. So we had to pick up a negative sign here. That's where that comes in. So when we do that, we find that we get a focal length that's plus 42.9 centimeters. So since it's positive, it has to be a converging lens. And converging lenses look like, kind of like oval-like. They take light and focus it to a point. That's what we're talking about here. Okay, so what does this have to do with prescriptions? So we can actually compute the power by doing 1 over the focal length. And since we have that number, we can just plug that in. We get this sort of weird unit, diopters, and we get plus 2.33. So this essentially is the prescription. This is the numbers that they usually put on glasses. They, 0.5, 1, 1.5, 2, and put a positive sign or negative sign to indicate whether it's converging or diverging. So here it's a positive one. So we usually don't find glasses in the small increments, but they do. You can find them in 0.25 increments. So we can find a glass pretty appropriate for him would be 2.25 in this case. That's something you can find in the store, usually at a gas station, pretty much anywhere. So there's the prescription. That's, that tells us what sort of number we're looking at on the actual boxes of the glasses. And if you want to test this out for yourself, if you're farsighted and you can't see near, you can always, take your hand and figure out what point can I not see clearly anymore. And you can roughly get an estimate, but probably should talk to your eye technician or someone else who knows more than me. But let's do an example where someone is nearsighted. So I'm nearsighted, so that may be more relevant to me. So, okay, so in this case, we want to see an object that's infinitely far away. And if you have healthy vision, you should be able to do that. So we can see the sun, we can see the moon, we can see stars and galaxies, and effectively those are infinitely far away, and we can still put that image and keep it sharp. But the problem with nearsighted people is that there's some maximum point where you can't see clearly anymore. So mine is about, I put my hand up, it's roughly my arm's length, I put it out, and it starts getting a bit blurry, and everything after that is blurry. So for this person, it's a little bit closer than mine, 40 centimeters, mine's probably 60 or 80 centimeters. But if you have a correction, you should be able to see these far away objects. So how do you calculate the prescription in this case? Well, we pull up the lens equation again, and 1 over the distance of the object, well, that's infinity, so that essentially goes to 0. We can just ignore that. So we get a pretty simple equation. 1 over the focal length equals 1 over the distance of the image. So we can just write this as the distance of the image. And note, again, it's on the same side, so it has to be negative, but it's just negative 40 centimeters. Okay, so since it's negative, it has to be a diverging lens. So that's the lenses that kind of look a little bit concave on each side. So what does that mean for the prescription? Well, again, pallor is 1 over the focal length, and that gives us 2.5 diopters, and that's perfectly a number that you'll find someone will sell you a pair of glasses for. For me, mine's a little less strong. It's like negative 1.75, so I can see a little bit further before it goes blurry, but there's the power. That's the actual prescription that you can find at a box somewhere and hopefully buy it, or usually with nearsighted you have to get it prescribed. But assuming there's no astigmatism or anything more complicated, that's how you would calculate the prescription. You just figure out for farsighted people, what's your near point, or if you're nearsighted, what's your far point? At what point do things start getting blurry? What point can you not see it? You can give you a rough estimation of what kind of glasses you need, although you should always probably talk to a technician or someone who knows a lot more about me about actually prescribing glasses. Anyway, that's all I have for today. Thank you as always for joining me. I really appreciate it. Okay.